The whole point of digital command control is to put a throttle to control the train in the hands of the locomotive operator. Every DCC system uses a controller of some kind to command the speed, direction, and headlight condition of the locomotives under its purview. To operate more than one train simultaneously, a throttle is required for each. Every throttle communicates with the command station across some transmission medium. If the throttles are not wirelessly connected in some fashion, the next wiring consideration is for a throttle network. This is usually some form of serial data transmission, often with error control, to allow multiple throttles to be plugged in at once. A throttle network is similar to a wired home computer network, in that a set of wires is run around the exterior edge of the layout with access jacks periodically located along the run. Most vendors have a special jack module available that can be attached to the layout fascia and connected to the throttle bus. The number of jacks and their spacing is arbitrary, within the distance constraints of the transport method employed by the throttle network. The last bit of wiring on the layout, which may or may not be DCC controlled, is the accessory power. Street lamps, building lights, signaling motorization, and the like require some level of voltage, typically 12 volts DC, to operate. Railroad power packs usually have a fixed 12-volt output specifically for accessories, and are not necessarily subject to throttle commands. Accessory buses can be installed right alongside the power feeders as required, with the accessory operating off smaller size wiretaps off the main bus just as rails do. If some form of control of the accessory is arranged via DCC, the DCC commands are usually taken off the rails while the operating power for the accessory can be taken from the accessory bus, leaving the DCC current for the locomotive. Track circuit polarity, how to prevent short circuits, and how to wire for DCC reversing loops is covered in Part 3.